Today we're going to look at inverse trig functions, and we've already looked at these a little bit when we dealt with our triangles. When we said, well, anytime you want to find an angle, you have to use inverse. So we've seen this a little bit. Inverse trig functions is when our calculator would do sine of inverse of 0.75. And we did that straight in our calculator to find theta. So we've kind of looked at it a little bit. We didn't really explain it or understand it. We just said, use this and it works. So today we want to explain a little bit more of what's going on. Now, first, I want to take a second and to refresh your memory about inverses. Now, when we want to find inverses, we had 3 steps. Our first step was to determine if it was 1 to 1. Did it pass the horizontal line test? Then we would switch the x and the y's. And third, we would solve for y. So refresh your memory. If I have f of x equals 2x plus 1, I can switch my x's and y's. Then I have to solve for y. And I get x minus 1 over 2. So my inverse is x minus 1 over 2. So another one. F of x equals e to the 2x. Now we didn't look at this when we did inverses because we hadn't learned about e yet. But same thing works. X equals e to the 2y. But now we have a problem. We can't just abstract multiply divide. We actually have to put this into logarithmic form, which is the natural log of x equals 2y. So when I solve for y, I get the natural log of x over 2. So my inverse function is the natural log of x over 2. So to do this, we needed this step here to go to logarithms to help us out. We have that similar problem when we try to do with our trig functions. So first, let's remind ourselves about sine. Now, if I was to graph sine, and I'm going to put not just one period, I'm going to put all these dots to try to do as close to a decent graph as possible. And if I connect the dots, here is a graph. Sine. Now, if we look at that graph of sine, we could say our domain of sine is all real numbers. Goes from negative infinity to infinity. And my range is from negative 1 to 1. Now you can see the problem though. This does a horrible job of passing the vertical line test. Let me use a better color to see that. It fails miserably. It intersects at an infinite number of places. And if I extended this line or extended my graph, it would intersect a whole bunch of times. So in order to have an inverse, it has to pass the horizontal line test. Sine doesn't. Doesn't work. So we need to do a little work. Here's what we're going to do. We are going to say, okay, as I look at sine, I want to change my domain, but not change the range. So I'm going to get rid of the domain, come up with something new, but I'm going to change, I don't want to change my range. Now, as you look at the graph of sine, if I went, let's say, from 0 to pi, that doesn't work. So that's not it. I could go from 1 to -1 here. That's kind of not quite right either. So what we're going to do from sine is the easiest is to say, well, if I go from -1 here, and I go up to 1 here, that has a range of 1. And my highlighter is not curving, so let me try a different color. If I go from here to here, that has the same range, but has a different domain. My domain is -pi/2 to pi/2. Now, that part of the graph, not this part, that now, and not this part is now 1 to 1, passes the horizontal line test, so I can find the inverse. So in order to find the inverse, the first thing we had to do is we had to restrict the domain and only look at part of the graph. Because if we looked at the whole thing, there was no inverse. Next, we had to figure out, how do we solve for y? I switched my x's and y's. Remember, our function was y equals sine of x. I switched my x's and y's. How do I solve for y? Well, what we're going to do is take the inverse sine of both sides. And since this is an inverse, the inverse sine of sine is just y. And so to solve for y, I get the inverse sine of x. There is my inverse sine. Now, we have inverse sine. So remember, our domain and range gets switched when we have an inverse. So go back here and notice my range is -1 to 1, and my domain is -pi/2 to pi/2. So when I find the inverse, that gets switched. So my domain is -1 to 1, and my range is -pi/2 to pi/2. Now, we have this sine equals inverse sine, the sine of -1 of x, and we also have arc sine. Sometimes you will see arc sine. Some places, some books use arc sine for this reason. If you remember, we have this problem of what this means, which is 1 over sine, which we write as cosecant a lot to not confuse with the inverse sine. So some people, to avoid the confusion, they say arc sine is what they use for inverse sine, and then secant's sine to the -1 exponent. I don't like using arc sine very often. I'll use inverse sine. Now the other thing I want to point out here is when you use inverse sine, it's only good from -pi/2 to pi/2. It only works on the right half of a unit circle. It doesn't give us answers on the left half. I'll see what I mean as we go here. So let's look at some examples. Inverse sine of 1/2. Now, inverse sine, I kind of think, once again, draw pictures helps a lot here. I kind of think of this like Jeopardy, where you're given the answer 1/2. They're saying the y-coordinate is 1/2. What's the angle? Well, I actually have two angles. I have this angle here, but I also have this angle here. Both of those have a y-coordinate of 1/2. How do I know which one is the right answer? We are only over here where the green is. That tells me that this angle is my answer. Now this is where your unit circle comes in. What is inverse sine of pi/2? That is, or excuse me, what's inverse sine of 1/2? That's pi/6. or 30 degrees. Unless the directions say you can do it in radians or you can do it in degrees. You can do it either way. Let's try another one. I'll erase my unit circle here. I think it helps me a ton to draw pictures. Sine of 1. So y coordinate of 1 is right there. There's only one answer, pi over 2. Sine of negative 1, inverse sine of negative square root of 2 over 3. Negative square root of 2 over 3 is right here. Square root of 2 over 2, excuse me. Once again, there's two possible angles. We don't use anything on this side of the graph, so my angle has to be right here. But notice our problem. I can't go around this way. I can't go to the left side over here. Effectively, we want to think about it is this half of the graph doesn't exist. So I can't even go that way around. My only way to get to that angle is to go down, and so my answer is negative pi over 4, or negative 45 degrees. I can't go around. It's only in these two quadrants. So if it's in the first quadrant, I go up to my angle to get my theta. If it's in the fourth quadrant, I have to go down to get my theta, and it's going to be negative. That's it. Your answers are only, let's think of degrees for a second. You only get answers from negative 90 to 90. You can't get 100. You can't get 200. You can't get 300. Negative 90 if it's in the fourth quadrant, positive if it's in the first. So your cosine. Cosine's almost the same, right? Negative infinity to infinity, negative 1 to 1. I'll go a little quicker here. Try to draw my graph pretty good. Now we can see cosine also doesn't really do real well on the whole vertical line test, or excuse me, horizontal line test. So we need to restrict it. Got to do the same thing. We got to restrict our domain to make it work. Now, I can't use the same thing. Negative pi over 2 to pi over 2. That doesn't work for cosine. So I got to change it. Cosine is 0 to pi. That stretch right there. So I have 0 to pi is my domain for cosine. That means my inverse, my arc cosine, my domain's negative 1 to 1, and my range is 0 to pi, which means I get answers from 0 to 180. So I get answers in those two quadrants. If cosine is positive, if the angle is positive, I get an angle in the first quadrant. If cosine is negative, I then get my angle that's in the second quadrant, from 0 to 180. Let's look at some examples. Cosine is square root of 3 over 2. Cosine's the x-coordinate. Square root of 3 over 2 is over here. So my angle is pi over 6, or 30 degrees. Negative 1 is over here. That's going to be pi. I'm looking, this is my x-coordinate, remember. What angle gives me this x-coordinate? When we were dealing with the sine, it was what angle gives me this y-coordinate? Remember, cosine's x, sine's y. Negative square root of 2 over 3. Well, negative square root is going to be about right here. So what is that angle going to be? That angle is going to be 3 pi over 4. Okay. Now, get a little bit harder when we have compound ones. So let's look at this. Sine of inverse sine of 1/2. And the way to do these is just do them one step at a time. Don't try to do the whole problem at once. Just do the inside part. Inverse sine of 1/2. This is my y-coordinate. What angle has a y-coordinate of 1/2? We've already looked at this. This is pi over 6. And then what is sine of pi over 6? 1/2. Inverse cosine of cosine of pi over 3. Cosine of pi over 3 is what we've already done. What is the x? What is, this is by theta. So what's the x-coordinate for a theta of pi over 3? And it's 1/2. Now this is saying what theta gives me a x-coordinate 1/2, and it's pi over 3. Think of it this way. Sine of an angle gives me a y-coordinate. Inverse sine of a y-coordinate gives me a theta. Cosine of an angle gives me an x-coordinate. Inverse cosine of an x gives me a theta. So that may help you keep straight what you're looking for and what you find as you do sine or inverse sine or cosine or inverse cosine. So let's do the next one. Inverse sine of sine of 2 pi over 3. Now so far they just kind of cancel each other out and they've worked. But that doesn't always happen. Let's look at this example. Sine of 2 pi over 3. Sine of 2 pi over 3 is square root of 3 over 2. But if you think of your unit circle, 2 pi over 3 is here. There's my sine. But when I do inverse, I don't get an angle over there. I get the angle over here. So my answer is pi over 3. So I don't get the same thing. Sometimes you do, sometimes you don't. Best is to do these step by step. Now, arctangent, we don't do a lot with arctangent, but just to show you, arctangent's the same as sine. It's in these two quadrants, negative pi over 2 to pi over 2. One thing that changes is for arctangent, it is negative infinity to infinity. So if I have inverse tangent of -1 or arctangent of -1, that means the tangent of what angle is -1? Well, that's going to be right down here, where they're the same, which is going to be minus pi over 4. Okay. Now, I do want to mention here on the calculator, we've done this already. And you can do inverse sine of 0.75. And you get your answer. But you have to be real careful here, because you can leave your answer in radians or degrees. So you just can't say 0.848. Because is that 0.848 degrees or 0.848 radians? So you got to check your mode. And my mode is in radians. Now, if I would change this to degrees, I'll get 48.59. So you either need 48.59 degrees or 0.848 radians. It's important you label your answer and know what mode your calculator's in when you get the right answer. On the homework, it's going to ask you to do some of these and to write your answer in radians. In some, it's going to ask you to write your answer in degrees. In some, it's going to not matter and ask you to not do it on the calculator and do it from the unit circle, and that's fine. You can do it either way. All right, homework on inverse trig functions.